The AIPMT 2014 question from friction. The problem is like this. A system consists of three masses M1 and M2, M3 connected by a string passing over a pulley as shown. You can see the diagram. Mass M1 hangs, M2 and M3 are on a rough horizontal surface of same coefficient of friction mu. The pulley is frictionless and of mass is negligible. It's the downward acceleration of M, assuming all masses are identical, right? The first thing that you need to know is, as there is a lowered weight, I can assume that this system moves down and this moves towards the left. So what are the forces acting here? I consider all masses are equal mg. There is an upward force tension. Let the acceleration of this equal to a, right? So for vertical mass, writing equation of motion. How do we write these equations of motions? Conceptually, I have explained in the Newton laws of motion chapter. You can find that in the playlist if you are not actually familiar with that. How do you write equations? But you must know by this time, actually. Yeah. So F resultant of that is MA is, as the body is moving downward, force downward has to be treated like positive. Tension is always towards the point of suspension, that is upward, so that is negative. Mg minus T. That's for that first one. Now, you can consider these two together as one system because their masses are equal and their coefficient of frictions are also equal. So, I can consider them as a single body. Of course, I can treat them as different bodies, but it will get one more equation and solving them takes little time. That's why I'm not doing it. Right? Okay. So here the tension is again towards the point of suspension. The frictional force acts against relative motion, that is against the motion. Motion is towards the left, so the frictional force is towards the right. So for horizontal masses together, I can write an equation of motion F resultant as m plus m of a, because there are two masses, this and this. Both all masses are identical as per the problem. Equal to, as this is moving towards the left, tension towards the left, that is towards the point of suspension of the pulley, treat as positive, minus frictional force, because frictional force is acting against the motion. So 2m into A equal to tension minus frictional force is mu into normal reaction. Normal reaction is 2mg because there is mass and mass, 2m's are there, right? Both their weights acts in normal downward direction. Normal reaction acts in upward direction. Yeah, normal reaction from each block is mg. For two blocks together, 2mg. So I got an equation as 2ma equal to T minus 2 mu mg. So what I can do is, I can find the value of tension from here. Tension equal to, because you want acceleration, tension has to be eliminated. Take this to the other side, it becomes plus 2 mu mg. Once I got this tension, let us substitute this tension in the first equation. That's of the first case, right? So, substituting tension in the first equation of motion. This is the first equation of motion. MA equal to mg minus tension. Tension is this much. That is 2ma plus 2 mu mg. So MA equal to mg minus 2ma minus 2 mu mg. So get this MA term to this side, it becomes a positive. MA plus 2MA equal to MG minus 2 mu MG. In all of this, M is common, that can be definitely cancelled. A plus 2A is 3A equal to G minus 2 mu G. So G can be taken common here. 1 minus 2 mu equal to 3A. So A equal to G of 1 minus 2 mu by 3. That's option number 3 is the answer for the problem. Right? So while we are solving the problem, we have taken some basic aspects into consideration. Let me tell you what they are. First thing, how do you write equation of motion? Whenever you are writing an equation of the motion, you shall consider in which direction the body is moving. Consider the force along the direction of motion as positive. Consider the force acting against the motion as a negative. See, MA is downward. MG is also downward, so I have treated it as positive. Tension is upward, always towards the point of suspension against the motion, so I have treated like negative. Once if you understand that, solving the problems on connected bodies becomes very easy for you. One more thing is here, I have considered three masses together so that problem will be little simplified. Otherwise, you will write an equation for M2 separately, you can write an equation for M3 separately. You will get one more tension in between, and that tension also has to be solved to get the acceleration. That's why we have not done that. That can be done that way also, but in a little lengthier way than this. That's why I have not done this, right? That's how we have to solve the problem. Thank you for watching.